Hello, good morning, welcome, Sunny Bona. This morning, this afternoon, this day, whatever time you're watching this DVD, we're presenting a topic to you called surds. But another name for surds is roots and another name is radicals. So, if somebody is speaking to you about surds or radicals or roots, they're talking to you about the same topic. Alright, so let's give you some examples of surds. Some examples. Square root of 4. Square roots, cube roots, can be any root, can be fifth root, for example, of 32, can be square root of 5. So whether it is square root, cube root, fifth root, so it can be any root. So if I say any root, I can write a letter like this. I can write n here, which stands for any number. I can write m here, which stands for any number. And of course, we say that n must be greater than 2 and m must be greater than or equal to 0, right? So, there we are. It can be square root, can be cube root, can be fifth root, it can be any root. Well, in this case, it's also square root, and sometimes we replace the numbers by letters. Now, it's very important to understand also that if I take a thing like square root of 4, then really there's a 2 that is understood here. Understood means this 2 is here, but it's not written. So that 2 is understood and you have a right to write it down like that. Okay? So only the 2 is understood. If it is 3 or 5 or any other number besides 2 will have to be written. Only the 2 is understood. So square root of 4 really means 2 root 4, which really means square root of 4. So the 2 is understood, and it's very important to know that fact. Alright, so that's the first thing. We've got to understand what are surds. Surds are any square root or third root or fifth root or fourth root or sixth root of any number. Alright, that's number 1. Number 2. If you're dealing with surds, you have to know what is called perfect squares. You must know them. So you can take your calculator and you can actually build this table up of perfect squares. If I start from 1, you see, 1 is a perfect square. 4 is the next perfect square. 9 is the next perfect square. 16 is the next perfect square. 25 is the next perfect square. 36, 49. I'll do the first 10. 49, that is 7. That's for 8. That's for 9. That's for 10. Now, why do we call this perfect squares? Because if you find the square root of 1 on a calculator, you'll find it will give you exactly 1. If you find the square root of 4 on the calculator, you'll find it will give you exactly 2. So that's why they are called perfect squares, because they have exact square roots. You see, they are exact square roots. Now, let's move on to perfect cubes. You must also know about perfect cubes. Here too, I will give you the first 10. 1, 8, 27, 64, 1, 2, 5, that will be for 5. For 6, it will be 2, 1, 6. For 7, it will be 3, 4, 3. That will be 7. For 8, it will be 512. For 9, it will be 729. And for 10, it will be 1000. So why are these called perfect cubes? Because if you find the cube root of 1 on a calculator, you will find it's exactly 1. If you find the cube root of 8 on a calculator, you will find cube root, you have to write the 3 here, you will find it's 2. So, you have to know these things. If you don't know them, you should take your calculator and build this table up and write it in your notebook some way. You see, you build the squares very easily. You build the squares like this. This is 1 times 1. This is 2 times 2. This is 3 times 3. This is 4 times 4. That is 5 times 5, etc. This is 1 times 1 times 1. This is 2 times 2 times 2. This is 3 times 3 times 3, and so on. So it's nice for you to build this. Just play with the calculator, keep building them, writing them on a page, so that when you're doing examples, they will come to you as fast as lightning. So because you need to know these things to work out examples on surds. Alright, so let's move on from here. Right, a few more things about surds. Note well. See, square root of 4 is really 2 root 4. So what happens is, if you have to rewrite this as without a square root sign, then we rewrite it as 4 to the half. So a replacement for a square root sign is index half. Similarly, a replacement for a cube root sign, right, is 8 to the 1/3. So the replacement for a square root sign is 4 to the half. Cube root of 8, replacement for the cube root sign is the index 1/3. And a few more general things. Let's take square roots. Number 1. This means square root of 4. And if you put in the calculator, you get the answer 2. If we have something like this written, plus minus square root of 4, then there are two answers. The answer is plus minus 2. In other words, the answer is plus 2 or minus 2. Number 3. Minus square root of 4 means we are only finding the negative answer, which is minus root 2. Minus 2, sorry. Or, put in another way, you find the square root of 4 and then multiplying it by minus 1, you're getting the answer minus 2. And finally, number 4, the square root of minus 4. If you put this in the calculator, if you put square root of minus 4 in the calculator, it will show you error. That's what the calculator will show you. So, square root of minus 4 cannot be determined. Square root of minus 4 is called an imaginary number. An imaginary or unreal number. Alright, so that's with square roots. And then I'm going to give you a little more general notes on cube roots now. Right, under cube roots, a few general notes. Look, the cube root of 8, if you put it in the calculator, you will see you get the answer 2. There's no problem there. Cube root, sorry. And I must write the 3 if it's cube root. Number 2. It is possible to find the cube root of minus 8, which is minus 2. See, that is 2 because 2 times 2 times 2 gives you 8. Here the cube root is minus 2 because minus 2 times minus 2 times minus 2 will give you minus 8. So, what we are saying that it is possible to find the cube root of a negative number. It is possible to find the cube root of a negative number. Alright, and then number 3, if we had minus cube root of 8, then it means find the cube root of 8 multiplied by minus 1, which will be minus 1 times 2, which finally becomes minus 2. Alright, just to show you the differences between square roots and cube roots. So, in summary, if this is an even number, in summary, right, to summarize, if this is a science, and if this is an even number here, and this number is negative, it's a negative number, then it is unreal. For example, 4th root of minus 16 is unreal because this is an even root of a negative number. But if it's an odd number here, but if it's odd here, then here you can have a plus or a minus number and you can still find an answer. Alright? So, if it's the even root here and a negative number, it's unreal, you will not be able to find the answer. But if it's an odd root, then it can be a plus number or a minus number and you will be able to find an answer. Alright, that's some general notes on surds, and then we'll go on to doing them section by section. So the first thing we're going to do is express, let's call this number 1, express as a mixed surd. Let us suppose we had square root of 18. If you try to find square root of 18 on your calculator, you will not get an exact answer. You will get a decimal fraction. But square root of 18 can be broken down into square root of 9 times 2. So, watch carefully what is happening. We are breaking 18 into a perfect square and another number. 18 is equal to 9 times 2. We're making sure that one of the numbers is the biggest possible perfect square. So 9 is the biggest possible perfect square. For this example, of course, we're looking at 18 and we're saying that inside 18, when we try to find its factors, 9 times 2, 9 is the biggest possible perfect square. Once we have that, we can then break this further and say this is square root of 9 times square root of 2. And then square root of 9 is 3 times square root of 2. Now, there's no need to write this multiplication sign, and therefore we can say that this is 3 root 2. So this is called a mixed surd because it is a surd mixed with a whole number. So that is the meaning of writing numbers as a mixed surd. So we took a surd and we wrote it as a mixed surd. Let's do another example. Square root of 200. So if I had square root of 200, then I will break up 200 into its factors. Now you've got lots of choices. 200 is 50 times 4. 200 is 100 times 2. But you see, 100 is the biggest possible perfect square inside 200. Therefore, we will not use 50 times 4. We are going to use 100 times 2. So you break up 200 into its factors, which is 100 times 2, making sure that one of the numbers is the biggest possible perfect square inside 200. And then you can break them down into its separate parts. Square root of 100 is 10 times square root of 2. No need for that multiplication sign. Therefore we say 10 root 2. So that is writing given surds as mixed surds. This is a surd, this is a whole number, that is why it's called a mixed surd. Now the same rule works for cube roots or any other root. So I'm going to do one example now involving a cube root. Alright, so now we're looking at cube root of 2000 and we are to express this as a mixed surd. Once again, you take cube root of 2000, you take cube root of 2000 and you break it up into two factors. And one of those factors must be the biggest possible perfect cube. You see, I can say 2000 is 200 times 10. This is no good because this is not a perfect cube, this is not a perfect cube. We want to put two numbers here. One must be a perfect cube and the other one, it doesn't matter. So if I look at 2000 again, it is 2000 is equal to say 500 times 4. That's also no good because none of these is a perfect cube. That's a perfect square, but I don't want square, I'm looking for a cube. So 2000 is equal to 1000 times 2. Now this 1000 is a perfect cube, so that's the right choice. This one is the right choice. So this is really 1000 times 2. So we break it up once again into cube root of 1000 times cube root of 2. Cube root of 1000, use your calculator to help you, is 10 times cube root of 2. No need for the multiplication sign now. 10 cube root 2. So in that fashion, we can break up any surd that we want. Now remember that this course is only on the basics, therefore I'm just doing square roots and cube roots, and once you get the idea with square roots and cube roots, you can handle any root. Alright, so we've done 3 examples. Now let's give you a little exercise where you can try to express numbers as mixed surds. Alright, so here comes the exercise. Alright, here is exercise 1. You got to express as a mixed surd. Square root of 18, square root of 48, number 3, square root of 500, number 4, cube root of 24, Number 5, cube root of 54. Number 6, cube root of 500. Alright, so now you must switch off the DVD and attempt the exercise and try the exercise. Alright, and we give you a few minutes to try that now. Best of luck. Alright, I hope you finished the exercise. Alright, here are the answers, and this is what you're supposed to have done. You're supposed to have broken that up into square root of 9 times 2. And that gives you square root of 9 times square root of 2, which is 3 times root of 2, which is finally 3 root 2. If you take number 2, if you study 48 carefully, right, the biggest possible square root inside over here is 16. So this is 16 times 3. If you thought of 4 times 12, it's not good, because you must think of the biggest possible square root. So 4 is not the biggest possible, 16 is the biggest possible square root. And that gives you square root of 16 times square root of 3, which gives you 4. Now I'm going to skip this step. 4 root 3. Alright? Square root of 16, 4. I don't have to write the multiplication sign. Root 3. So I can now skip that step here. If I look at square root of 500, square root of 500, the biggest possible square root inside 500 is right. The biggest possible square root inside here is 100 times 5. So 100 times 5 gives me 500. So that will become square root of 100 times square root of 5. Square root of 100 is 10. I don't have to write the multiplication sign, so I leave that out. And next to it, root 5. So that's 10 root 5. Now, in number 4, you must be careful. This is a cube root sign. So, we want to break up 24. We want to break up 24 into the biggest possible cube. So earlier on I gave you the table of cubes. 1, 8, 64, 27, etc. So the biggest possible cube inside here is 8. So this is 8 times 3. You see, 8 is a perfect cube. Right? So 8 times 3 gives you 24. And 8 is a perfect cube. So you break it up further. Cube root of 8 times cube root of 3. Cube root of 8, get your calculator to help you, it is 2. I don't have to write the times, I don't have to write it, it's understood. And I can just write next to it cube root of 3. So I could have written the answer like this, or you could have gone 2 times cube root of 3, which is equal to 2 cube root 3. But this step, you don't have to write it. You can now leave it out because you are used to this thing now. Right, let's look at number 5. Cube root of 54. So go and look at your table of cube roots that we gave you earlier on, and you'll find that the biggest possible cube root inside here is 27, because 27 times 2 gives you 54. And 27 is a perfect cube. So, if you rewrite that, separately. We've got cube root of 27. Now, I can write it like this. I can write cube root of 27, cube root 2. I can write like that too. I can use brackets if I want to. And then cube root of 27 is 3. And what's left here? Cube root of 2. So, I can even use brackets like that. So that answer is 3 cube root 2. And finally, we have cube root of 500. So if you study 500 carefully, you'll find that the biggest cube root inside 500 is 125 times 4. You see, 125 times 4 gives you 500. So, cube root of 125 times cube root of 4. If it's cube roots, you must write the 3's. Cube root of 125 is 5. I don't have to write the multiplication sign now. And then next to it, cube root 4. Alright, so I hope you had 6 out of 6. If you didn't, all you've got to do is find your mistake and redo the exercise till you score 6 out